Born out of compromise and developed from a medium bomber project, the Lancaster went on to become the most successful British heavy bomber of the Second World War. Its development began when fighting had already been raging across Europe for 3 months. But by the time the war ended, about 7,300 of these aircraft had rolled off the line. The bomber was used so intensively by the Royal Air Force that nearly half of them, 3,345 aircraft, were lost on operations. From 1942 to 1945, Bomber Command Lancasters flew an astonishing 156,000 sorties. Over that time, they dropped more than 660,000 American tons of bombs on enemy targets. Among them were the massive 22,000-pound Grand Slam bombs, which no other production aircraft of the period could carry, the 12,000-pound Tallboy bombs, and Barnes Wallis's famous bouncing bombs, specially designed to destroy enemy dams. In 1939, Avro was deeply bogged down in the Manchester production program, one of the more promising medium bomber projects of the time. It was originally intended to be a large twin-engine bomber powered by Rolls-Royce Vulture engines. But the Vulture was developing too slowly, and its early performance was so disappointing that the whole bomber program was placed in serious jeopardy. Their competitors at Handley Page quickly saw the problem, and before the end of 1937, they made a radical decision to redesign their project, replacing the 2 troublesome Vultures with 4 reliable Merlin engines. That was how the famous Halifax bomber came into being. Avro's airplane, meanwhile, remained the only one still tied to those temperamental power plants. The British had planned to launch large-scale Manchester production across several major aviation companies. But constant technical trouble and continuing uncertainty around the Vulture kept forcing those ambitious plans to be delayed and revised. In that difficult situation, the real saving grace was that Avro's design team, led by Roy Chadwick, had already begun looking for backup options in 1939. They decided to see whether 2 Vultures could be replaced with 4 well-proven Merlins. At first, the Air Ministry pushed for other engines, including the Sabre and the Centaurus, but that idea was soon dropped in favor of a 4-engine design using Merlins. The conversion turned out to be surprisingly elegant and straightforward. The engineers kept the old fuselage, tail assembly, and center wing section, simply modifying the existing mounts for the new engines. Then they added extended outer wing panels with space for 2 more power plants. The company's calculations looked very promising. The new 4-engine giant was expected to take off at a maximum weight of more than 57,000 pounds. At the same time, it could carry 12,000 pounds of bombs out to 1,000 miles, or take 8,000 pounds of ordnance and fly 1,600 miles at 245 miles per hour. And if the pilot shifted to a more economical cruise, dropping speed to 190 miles per hour, the range increased dramatically. With a heavy load, the bomber could cover 1,350 miles, and with a lighter one, a full 2,000 miles. Those figures made it clear that the new Avro 683 had much greater potential and promised far better performance than its predecessor, the Manchester Mark I bomber. And even though demand for Merlin engines was enormous at the time, British planners were preparing to expand their production across several different factories. On top of that, the decision to cancel the Vulture, which was used only on the Manchester and nowhere else, freed up desperately needed manufacturing capacity. Those facilities could now shift entirely to building Merlins. The Air Ministry believed that Avro 683 was slightly inferior to the Handley Page 57 bomber, but it had an obvious and undeniable edge over the old Manchester. So on November 15, 1940, the final decision was made to put the new 4-engine version into production. That was to happen as soon as the earlier orders for standard Manchester bombers had been completed. Since the changes to the design turned out to be much more serious and far-reaching than they first appeared, one very reasonable thought followed right away. This airplane needed a new name of its own. That was how the revised specification appeared, setting the standard for what would become the future legend, the Lancaster Mark I bomber. The requirements were demanding. The new bomber had to cruise at 250 miles per hour at about 15,000 feet. At the same time, it needed to carry 7,500 pounds of bombs for 2,000 miles, with a maximum range of 3,000 miles. The huge bomb bay had already been one of the Manchester's defining features, and naturally, it was retained in the new Lancaster. From the beginning, the aircraft was meant to carry a wide range of bomb loads. That could mean one giant 4,000-pound bomb and 6 500-pound bombs. Or, alternatively, 6 large 1,500-pound naval mines, or more complex combinations of 2,000-pound heavy bombs, 250-pound lighter bombs, and more than a dozen smaller weapons. The official order for the first Lancaster prototypes came in that same year, 1940. Since Avro's engineers were able to make good use of existing Manchester parts, work moved incredibly fast. The first prototype was completed by the end of the year, and it made its historic first flight on January 9, 1941 at Woodford. At first glance, that prototype looked like nothing more than a 4-engine version of its predecessor. It had the same tail assembly with a relatively small span of 22 feet, the same twin end-plate fins, and a large center fin that helped with directional control. But the new outer wing sections increased the overall span considerably, bringing it up to 102 feet. From the earlier design, the aircraft also inherited the Fraser-Nash nose and tail turret arrangements, though it still lacked both dorsal and ventral defensive positions. While the first prototype was going through detailed handling and general flight trials at Boscombe Down, a second prototype was already being prepared at Woodford. It took to the air for the first time on May 13, 1941. On that airplane, the engineers installed an improved tail unit with a span of 33 feet. It featured larger fins and rudders. That configuration later became the standard for all production Lancasters and was even adapted to later Manchester versions. The second prototype also received a full defensive armament fit. It carried a nose turret with 2 machine guns, a powerful tail position with 4 guns, and both ventral and dorsal turrets, each armed with 2 machine guns. The trials quickly showed that the Lancaster was an aircraft of exceptional capability. As early as March 1941, reports from the test center noted that it had excellent flying qualities and tremendous combat potential. During tests with the first example, the bomber reached a true speed of 242 miles per hour at 4,600 feet. And that was with its Merlin 20 engines running on a maximum lean mixture and a boost pressure of only about 4 pounds per square inch. A little later that year, the military tested the second prototype at an artificially increased takeoff weight of a massive 60,000 pounds. The results impressed the experts. They concluded that the aircraft would still be able to take off confidently and climb quickly even at a gross weight of 61,500 pounds. Inspired by the impressive results of those first trials, the Air Ministry made a decisive move. They shut down further Manchester production entirely in order to throw every effort into accelerating Lancaster output. From that point on, the new bomber became the central hope and took a leading place in the strategic plans of the command. Because of that sharp change in priorities, Manchester production never came close to the figures originally laid out in contracts with Avro and Metro Vickers. The shortfall under those agreements, 43 aircraft from Avro and 57 from Metro Vickers, was simply made up with brand new Lancasters. One interesting detail is that although the first 2 Lancaster prototypes did make use of parts from production Manchesters, they were not officially treated as simple modifications of the earlier bomber, despite how often that gets repeated. In reality, they were considered an entirely separate addition to the existing production contract. The first production Lancaster rolled off Avro's line immediately after the last Manchester. This striking bomber first took to the skies over Woodford on October 31, 1941. Less than 2 years had passed since work on the project began, which was a real technological leap. And by the end of that same year, another full dozen of these powerful bombers were already ready for operational sorties. The first official mass production order for the Lancaster came on June 6, 1941. It called for 454 aircraft and effectively canceled the earlier order for 450 Manchesters that had been placed in early 1940. More and even larger orders followed soon after. Earlier, the British had planned to create a whole group of factories specifically for Manchester production. Now, all of those industrial plans and resources were redirected exclusively toward building Lancasters. The agreement with Metro Vickers was quickly rewritten for the new bomber. Over 1941 and 1942, other industrial giants joined in as well, including Armstrong Whitworth, Vickers Armstrong, and Austin Motors, all of them setting up assembly lines at plants in different parts of the country. Avro initially centered its production in Manchester with final assembly and flight testing at Woodford. Later, as output had to be expanded, the aircraft also began to be assembled at a new plant near Leeds. At one point, a batch of 200 Lancasters was even ordered from Short Brothers and Harland in Belfast, but in practice that contract never moved beyond paper. Not a single airplane was built there. The Lancasters' production process was remarkably well thought out. It was greatly simplified by dividing the aircraft into 36 large independent modules. For example, a complete fuselage or wing could be assembled by joining just 5 major sections. The fuselage had an oval cross-section and was built entirely of metal, which gave it impressive strength. Its structural backbone consisted of paired, pressed members running along the lower part of the center section. Strong transverse bulkheads between those members supported the cockpit floor, which at the same time served as the roof of the huge bomb bay below. The center wing section was essentially rectangular, while the outer panels, where the outboard engines were mounted, had graceful tapering, leading and trailing edges that blended into rounded tips. The whole wing structure was carried on 2 massive spars. Each spar was a sturdy combination of upper and lower booms bolted together. The frame was then skinned in smooth sheets of light but durable aluminum alloy. In flight, the main landing gear legs retracted backward under hydraulic power into the inner engine nacelles. The enormous landing loads were taken by special castings made from high-strength light alloy. Interestingly, the small tail wheel was fixed in place and did not retract into the fuselage. The designers made a practical choice there. The slight aerodynamic penalty was more than offset by the weight saved, since there was no need to run heavy hydraulic lines and mechanisms all the way back into the tail. Flying this giant called for a coordinated crew of 7. The crew usually consisted of an experienced captain, a second pilot, a navigator who also handled precise bomb aiming, 2 radio gunners, and 2 additional air gunners defending the bomber against enemy fighters. To protect them in the air, the cockpit area was carefully armored, with the armor integrated directly into the aircraft's structure. The gun positions, or turrets, were also heavily protected. In addition, a large armored bulkhead was installed in the middle of the fuselage. It had only a narrow passage cut through it, allowing the crew to move safely across the aircraft above the bomb bay packed with explosives. During the Christmas holiday period of 1941, the first batch of new aircraft arrived at a British airbase. That unit was chosen as the first to convert completely from the older twin-engine Hampton bombers to Avro's powerful 4-engine giants, the now famous Lancasters. At the same time, the test center began intensive flying with 2 aircraft to identify and eliminate any possible teething problems as quickly as possible. The Lancasters got their first taste of combat on March 3, when 4 crews successfully laid naval mines. A week later, 2 bombers flew their first actual bombing raid. 10 days after that, a second squadron entered combat as well, also laying mines off the coast. But the excitement over the new bombers did not last long, and before long, the whole fleet had to be temporarily grounded. The reason was a serious incident. During a hard maneuver under heavy load, one Lancaster literally lost its wingtips and crashed in an emergency landing. Even more trouble followed in April when the upper wing skin failed during testing, leading to the loss of another aircraft. That forced the engineers to inspect and strengthen the structure of all the bombers already built. In general, the first flights and real combat experience quickly began dictating the next changes. Modifications were absolutely necessary. Some were made to improve crew safety, some to expand combat capability, and others were simply part of the aircraft's natural evolution. For example, the ventral turret turned out to be almost useless in actual combat. Since it was removable, it was simply taken off the aircraft that had been delivered with it. A fairing was also installed around the dorsal turret. It reduced drag, but it also worked as a limiting ring, preventing overly eager gunners in the heat of battle from accidentally riddling their own tail with bullets. Interestingly, the first 6 Lancasters differed from the rest. They had only 4 fuel tanks in the wings, with a combined capacity of a little over 2,050 gallons. Later, the engineers realized that was not enough. They enlarged the outer tanks and added new ones even farther out along the wing, bringing total fuel capacity up to nearly 2,590 gallons. Even though the Lancaster already had one of the largest bomb bays of any bomber of its time, the designers pushed things further. They developed an entirely new suspension system. Thanks to that, the aircraft could carry a colossal 8,000-pound bomb, even though the original specification had never envisioned anything like that. To fit those monsters weighing 8,000 or even 12,000 pounds, The bomb bay had to be enlarged slightly by reshaping its doors. The first version of that major modification was successfully tested on the second prototype. The Lancaster was built in huge numbers, but over the entire war, it had only 4 production variants, 2 major and 2 minor. In aviation terms, that says one thing. The basic design was extremely sound from the start. The Lancaster Mark I remained on the production line right up to the end of the war, with hardly any major change from the time it entered service in early 1942. The real jump in performance came with newer versions of the Merlin engine. At first, the standard power plant was the Merlin 20. It produced 1,280 horsepower for takeoff at a boost pressure of about 12 pounds per square inch, and at 6,000 feet, it reached a maximum output of 1,480 horsepower. With those engines, the aircraft's maximum weight was limited to 61,500 pounds. Early in its career, the Lancaster Mark I could reach 287 miles per hour at 11,500 feet, had a service ceiling of around 24,500 feet, and a range of 1,660 miles, carrying 14,000 pounds of bombs at a cruising speed of 241 miles per hour. But progress did not stand still. The arrival of the Merlin 22, with boost increased to 14 pounds per square inch, raised the maximum takeoff weight to 63,000 pounds. In real combat conditions, a heavily loaded Lancaster Mark I with those engines cruised at 270 miles per hour at 19,000 feet. Its range reached 2,450 miles with nearly 19,500 pounds of bombs, and a little over 1,000 miles with a 14,000-pound bomb load. Even more impressive figures were reached in late Lancaster Mark I aircraft fitted with Merlin 24 engines. These power plants ran at a strong boost of 18 pounds per square inch and delivered 1,620 horsepower at takeoff. With that kind of power, the bomber could lift more than 68,000 pounds into the air, and in some exceptional cases as much as a staggering 72,000 pounds. In all, 3,434 production Lancaster Mark I bombers were built, not counting the first 2 prototypes. Later came another version, the Lancaster Mark III, with more than 3,000 examples produced. Visually and in performance terms, it was almost a twin of the Mark I. The main difference was under the cowling. Instead of British-built engines, they used Packard-built American Merlin 28 and Merlin 38 engines. These American power plants delivered the same boost levels as the British Merlin 22 and Merlin 24. Rolls-Royce first experimented with American-built Merlins in August 1942. They installed them in the first Lancaster purely for testing. The results were successful, and that same year Avro produced the official prototype of the Mark III. Although the aircraft flew essentially the same as the first version, it received a separate designation because the American engines required different maintenance procedures. A little later, when the Royal Air Force introduced a new classification system, these aircraft received the designations B Mark I and B Mark III, respectively. Production of the Mark I became a true nationwide effort, involving 5 major companies in what was known as the Lancaster Group. To show the scale of it, Avro built 894 aircraft. Metropolitan Vickers produced 944, Armstrong Whitworth turned out 911, Vickers Armstrong added another 535, and Austin Motors built 150 bombers. It was a massive cooperative effort spread across factories all over the country. As for the Lancaster Mark III, Avro was by far the leader, building an impressive 2,776 aircraft. Metropolitan Vickers and Armstrong Whitworth supported that effort with 136 and 118 more respectively. By the end of 1941, Lancaster production had increased so rapidly that a real concern emerged. There might simply not be enough Merlin engines for all the new airframes. To keep the line from stopping, the engineers began work on the Lancaster II. The defining feature of that version was the replacement of the scarce Merlins with powerful Bristol Hercules 6 engines, each rated at 1,725 horsepower. The first prototype of that model flew on November 26, 1941, just 1 month after the first flight of the production Lancaster Mark I. In addition to its new engines, the version had a slightly larger bomb bay and an extra Fraser-Nash 64 ventral turret. Production of that variant was assigned to Armstrong Whitworth, which built 300 of them in total. Later batches were fitted with improved Hercules 16 engines. There was one serious drawback, though. Although the speed of the Mark II remained roughly on par with the first, its service ceiling at full load dropped noticeably to about 15,000 feet. So as soon as the shortage of Merlin engines eased, plans for continued production of the Mark II were quickly abandoned. The 300 ordered aircraft were converted back to the B-1 standard. As for other late versions, such as the 6th, 7th, and Canadian 10th model, they had their own particular features, while projects known as the 4th and 5th models were developed into entirely separate aircraft with new names, Lincoln I and Lincoln II. Overall, 1942 was a turning point in production of these bombers. At the start of the year, factories were turning out only 23 aircraft a month. By December, that had risen to 91. The absolute peak came in the fall of 1944, when an incredible 260 bombers were being assembled each month. Of all the combat aircraft built in Great Britain, only the Spitfire and Hurricane were produced in greater numbers. One interesting detail is that until mid-1943, the rival Halifax heavy bomber actually outpaced the Lancaster in total production. But once Lancasters began to be used in large numbers in actual combat, their clear operational advantages became obvious. Because of that, Halifax production was gradually reduced, and its later versions were even pulled from offensive operations. The Lancaster, meanwhile, firmly established itself as the main tool of the strategic bombing offensive against Germany and secured its place in aviation history. The first combat sorties flown by Lancasters began in March 1942. That happened just a few weeks after Bomber Command came under Air Vice Marshal Arthur Harris, later known as Bomber Harris. From that point on, tactics changed dramatically. Instead of pinpoint attacks on individual targets, British air power shifted to mass bombing of large urban and industrial areas. Re-equipment with the new bomber moved at a furious pace. The first group to receive Lancasters was 5 Group, and within a year, all of its crews were flying nothing else. Later, as more new aircraft arrived from the factories, other units transitioned to the Lancaster as well. By the end of the war, half of the Canadian crews fighting in Europe were flying these bombers. The same was true for 6 squadrons of the elite Pathfinder Force in 8 Group. Archival records show that by that spring, no fewer than 57 squadrons equipped with Lancasters were operating at the front. Most pilots flew the B Mark I and B Mark III variants, although Canadian crews often used locally built aircraft known as the B Mark X. In early 1943, the Lancaster Mark II was first tested under combat conditions. The defining feature of that model was its powerful radial engines. Before long, entire squadrons began to receive these aircraft in large numbers, and once again it was Canadian aircrews who got the largest share of those unusual bombers. From the middle of 1942 right to the final months of the Second World War, the Lancaster remained Bomber Command's main and deadliest weapon. These were the bombers that relentlessly hammered strategic targets across the Third Reich. Service on these aircraft demanded real courage. Over the course of Lancaster combat operations, 10 crew members were awarded Britain's highest military decoration, the Victoria Cross. Roughly a year after its combat debut, on the night of March 5 to March 6, 1943, Lancaster crews began the large-scale campaign that would go down in history as the Battle of the Ruhr. It was a series of continuous and destructive attacks on the major industrial centers of the Ruhr region, including Essen, Duisburg, Düsseldorf, Dortmund, and Bochum. Key German cities such as Berlin, Munich, Stuttgart, and Nuremberg also came under attack. In July, Hamburg was engulfed in a storm of fire, and by November, the capital itself had become the main target. Over the next 5 months alone, Berlin endured 16 major air raids. From March through September 1944, Bomber Command's enormous power was redirected toward preparing for the Allied landings in Europe. The bombers now methodically destroyed rail hubs and airfields in France, wiping out defensive positions that stood in the way of the advancing armies. After D-Day, their targets included the launch sites of German WWII weapons. And when the strategic bombing of Germany resumed with renewed force in the fall of 1944, the Luftwaffe no longer had the resources for an effective air defense. Sensing their advantage, Lancasters began flying more and more of their attacks not just by night but in daylight as well. Besides the familiar and exhausting night raids on German cities, Lancasters also took part in special operations that were widely covered in the press. The first of these was the attack on the MAN factory in Augsburg, where diesel engines for submarines were produced. The risky mission was flown in daylight. A strike force of 12 bombers went in at low level in tight formation. The cost was extremely high. 7 of the aircraft never came back. That raid, carried out on April 17, 1942, became the first air operation that was widely and loudly discussed in public. Although the actual physical damage to the German plant was minimal, the raid had enormous psychological value. It vividly showed the world that British air power was growing rapidly and could reach the enemy deep in the rear, even at great distance. Then, at the end of May 1942, Lancasters took part in the famous 1,000-bomber raid on Cologne, though at that point there were still relatively few of them in the air. By October 1942, 5 Group had 9 squadrons flying the famous Lancaster heavy bomber. This powerful air formation was used in a major daylight raid that took place on October 17th. A total of 93 aircraft were sent on the mission to bomb the Schneider Armaments Works in Le Creusot, France. The operation went remarkably well, and the Allies lost only 1 bomber. Toward the end of that same year, Lancasters were first ordered to attack targets in Italy. Their crews had to cross the harsh Alps carrying 4,000-pound and 8,000-pound bombs, along with large numbers of incendiaries before dropping that destructive load on the industrial centers of Genoa and Turin. Later, the accuracy of these bombing missions improved dramatically. That happened thanks to the introduction of the new H-2S airborne radar. This innovative system helped crews orient themselves more confidently and locate enemy targets even in poor visibility. The radar itself was housed under a special translucent fairing on the underside of the rear fuselage. It was first used by crews of 49 Squadron in August 1943. However, those radars were not fitted to aircraft with enlarged bomb bays, which were mostly assigned to 3 group squadrons. But the most remarkable and most dangerous of all Lancaster operations was the night raid on the dam network in western Germany. This bold mission was carried out brilliantly by 617 Squadron on the night of May 16th to May 17th, 1943. The operation was given the code name Upkeep. Bomber Command approved it in late February, immediately after the successful completion of the preliminary trials. Those tests involved half-scale versions of the unique weapon designed by the brilliant engineer Barnes Wallis of Vickers Armstrong. The results showed that the mission had every chance of succeeding. The main targets selected for the devastating strike were 6 strategically important German dams: Moone, Eder, Zorpu, Enupu, Lister, and Schwelme. To carry out the mission, the command ordered 20 production Lancasters to be specially modified and also set aside 3 experimental aircraft. The secret weapon itself, in its final form, looked like a massive steel cylinder. It measured 50 inches in diameter, 60 inches in length, and weighed more than 9,250 pounds. Of that total, about 6,600 pounds was highly powerful DX explosive. Picture a typical German dam of the time. It was essentially a fortress, a massive concrete wall, 112 feet thick at the base, narrowing to 25 feet at a height of 130 feet. To breach something that formidable, an ordinary air attack would not do. The bomb had to explode underwater, right up against the face of the wall. The task seemed almost impossible for the bombs and mines of the time, but Barnes Wallis came up with a brilliant idea. What if the bomb were spun up before being dropped from the aircraft? In his concept, it would bounce across the water like a skipping stone until it struck the dam wall. Then it would sink and explode under water pressure at a depth of about 30 feet. These dams were strategically vital because together they formed a hydroelectric system powering the entire Ruhr industrial region. Destroy even a few of them, and German industry would suffer enormous damage. On top of that, water from the reservoirs would rush downstream at once, flooding the valleys below and sweeping away everything in its path. May was the ideal time for the attack because the reservoirs were full then. But British command was not especially enthusiastic at first, since they did not want to pull a Lancaster heavy bomber squadron away from regular operations. In the end, though, a completely new and special unit had to be created for this ambitious mission on March 21, 1943. The unique bomb, given the working name Type 464, was built by Vickers. At the same time, Avro engineers sent drawings to the factory in March 1943 so that the aircraft could be urgently modified to carry this unusual weapon. The changes to the bomber were drastic. The bomb bay doors had to be removed entirely because the huge bomb would not fit inside the fuselage. To reduce weight as much as possible, the dorsal turret was also removed completely. The bomb itself was mounted crosswise under the fuselage between two large V-shaped frames. At the ends of those frames were special discs that fit tightly into recesses on the sides of the weapon. Through a belt drive, a hydraulic motor spun one of those discs, bringing the bomb up to an incredible 500 revolutions per minute before release. Since the bomb bay doors and dorsal turret had been removed, the Lancaster's regular hydraulic system had enough power to handle the process. It switched over to spinning the bomb as soon as the pilots retracted the landing gear. The mission demanded precise flying at extremely low altitude. The bomb had to be dropped from just 60 feet above the water. Because of that unusual flying profile, the ventral gun was moved to the floor of the fuselage just aft of the bomb bay. A padded mat was even laid down for the gunner because he had to work and aim while kneeling. To improve aerodynamics, special fairings were fitted fore and aft of the open bomb bay. But the most important part was aiming. The engineers devised a unique triangulation sight. It used the towers at the edges of the dam to let the crew release the weapon at the perfect distance, between 400 and 450 yards from the target. And to hold the exact low altitude, the aircraft were fitted with two spotlights. Their beams met in a single point on the water surface precisely when the bomber was down at the required 60 feet. All 23 Lancasters modified in this way were standard B-3 aircraft fitted with powerful Merlin 28 engines. The first of the 3 test prototypes arrived at the RAF Test Center at Farnborough on April 8, 1943. The second was sent straight to Ruhr in Kent for practice drops. Meanwhile, the third aircraft spent the whole of April undergoing hard handling trials in the air with that awkward external load. By April 18th, the first of the 20 operational aircraft had arrived at Scampton, directly for the use of the now legendary 617 Squadron. Ahead of the crews lay an entire month of exhausting training, both day and night. Then, on the night of May 15th, 19 aircraft took off. One bomber had to be left behind because it had been badly damaged during training 5 days earlier. The strike force approached the target in 3 waves. The first wave, made up of 9 aircraft, was led personally by Wing Commander Guy Gibson. The other 2 groups had 5 aircraft each. The first wave's main task was to strike the 2 most important targets, the Mona and Ader dams. The second wave, which technically took off first, was sent against the Zorpu dam. The third group acted as a mobile reserve and was assigned to attack 3 dams, Zorpu, Enapu, and Lister. Unfortunately, only the first wave truly succeeded. 5 bombers were able to drop their bombs on the Mona Dam, ultimately causing its complete destruction, though 1 aircraft was shot down in the attack. Of the remaining bombers, 3 attacked the Zorpu Dam, while another successfully breached the Ader Dam. In addition, 2 bombs were dropped on Zorpu and 1 on Enapu, but those caused no serious damage. The price of that bold and innovative mission was extremely high. 8 of the 19 Lancasters never came back from the skies over Germany. The famous British Lancasters continued to be improved. At first, their bomb bays were enlarged to accommodate the massive 8,000-pound bombs. But before long, it became clear that the aircraft could lift an even heavier weapon, a 12,000-pound version of the same basic design. It was slightly longer but kept the same diameter. On top of that, the reshaped bomb doors proved ideal for carrying the new aerodynamic 12,000-pound Tallboy bomb designed by the remarkable engineer Barnes Wallis. The first crews to use this destructive weapon in combat were the pilots of the now famous 617 Squadron. Interestingly, they had only just turned in their earlier specially modified aircraft after the high-profile dam operation. One of Tallboy's first combat missions was the attack on the railway tunnel at Saumur in France. It was a strategically important target because German command used it to move reinforcements toward the Normandy front. On the night of June 8th to June 9th, 1944, the tunnel was successfully blocked, seriously disrupting enemy logistics. The next major target was the German battleship Tirpitz, hiding in the Norwegian fjords. On September 11, 1944, 38 Lancasters of the first and third variants took off from airfields in England. Their route led to the Yagodnik airfield near Arkhangelsk in the Soviet Union, where the crews were to prepare for the decisive strike. The attack itself took place on September 15th. 21 aircraft carried heavy Tallboy bombs, while another 6 were armed with special anti-shipping weapons. The bombers managed to hit the pride of the German fleet, but the huge Tirpitz remained afloat. And this was far from the first attempt to use Lancasters against warships. Back in the spring, on April 27, 1942, just a month and a half after beginning combat operations, British bombers had already tried to destroy Tirpitz at Trondheim. On that occasion, they dropped 4,000-pound bombs on the battleship, but the mission achieved nothing. The story of the battleship reached its conclusion in October 1944. Tirpitz had moved to Hakoya near Tromsø. That proved to be a fatal mistake because now she was within Lancaster range directly from Great Britain. Two of the best squadrons were immediately moved to Loss-e Mouth to prepare for another strike. By then, the aircraft had undergone serious modification. They were fitted with more powerful Merlin 24 engines and converted into an updated B Mark I version. To get the required range, the engineers had to make some trade-offs. The dorsal turrets were removed to save weight, and extra fuel tanks were installed inside the fuselage. That pushed total fuel capacity up to an impressive 2,890 gallons. In the late October attack, the crews dropped 32 Tallboy bombs, but not one of them scored a hit. The air crews did not give up. A third raid, this time a successful one, took place on November 12th. 28 bombers dropped their deadly load. 2 direct hits proved critical, and the giant warship capsized. After that, 9 and 617 squadrons earned their reputation as true experts in precision bombing. That level of accuracy was absolutely essential if the full potential of the Tallboy earthquake bomb was to be used. In all, Lancaster crews dropped 854 of those bombs during the war, and the overwhelming majority came from those 2 squadrons. Technical progress kept moving, and before long, the Lancaster was adapted to carry an even more devastating weapon, the giant 22,000-pound Grand Slam bomb. Its streamlined aerodynamic shape closely resembled the Tallboy. Naturally, the right to use this monster was entrusted to the best crews. Work on the first modified test aircraft began in October of 1944. Flight testing started in February 1945 and went so well that the military immediately ordered 32 production aircraft. This special version, with a takeoff weight of more than 72,000 pounds, became known as the Lancaster Special. These bombers were fitted with Merlin 24 engines, and to save weight and improve aerodynamics, the nose and dorsal turrets were removed and the bomb bay doors were replaced with smooth fairings. A Grand Slam bomb was first dropped from a Lancaster on March 13th, during final trials on the range. The very next day came its combat debut. 14 aircraft carrying Tallboys and 1 armed with a Grand Slam struck the Bielefeld viaduct and destroyed it completely. That giant bomb was the first of 41 dropped by the squadron before the war ended. Interestingly, there was only one other unit that ever flew those special Lancasters, 15 Squadron. But they received their aircraft only after hostilities had ended. While most of the famous Lancasters served with the main force of Bomber Command, several squadrons carried out another critically important role, target marking. In August 1942, the British formed a special elite force for that work. At first, it included only 1 Lancaster squadron, but by the spring of 1943, a second had joined it. Over the next 2 years, the group expanded rapidly as new units were added. These crews flew Lancaster Mark I and Lancaster Mark III aircraft. Interestingly, those large bombers needed very little modification to carry the special pyrotechnic target markers used to illuminate aiming points. Over time, they also received advanced navigation aids and sights. That allowed the crews to reach enemy targets ahead of the main force, drop marker flares into the night sky, and guide the following waves of heavy bombers onto the objective. In 1944, the target marking units received a small batch of unusual aircraft, the Lancaster 6. This model emerged from a major government program aimed at developing an improved bomber. That project later led to the Lancaster 4 and 5, which were eventually renamed the Lincoln 1 and 2. The history of the 6th model began in the middle of 1943, when 2 standard Lancasters were handed over to Rolls-Royce for trials with the new high-powered Merlin 85 engine. The engineers quickly realized that if those 1,635 horsepower engines were installed in the standard Lancaster airframe, the aircraft would gain an entirely new level of capability. That gave birth to the prototype of the 6th series, which first flew in early 1944. Only a few were built, and just 4 reached frontline service. Their main role was electronic warfare. They dropped window strips of metallized foil, along with a small number of bombs well away from the real target in order to deceive German radar and create the illusion of a mass raid somewhere else entirely. Thanks to the new engines, the Lancaster Mark VI had excellent performance, which made it very hard for enemy fighters to intercept during those solitary night missions. But the Merlin 85 proved too temperamental and insufficiently developed, and by November 1944, those aircraft were withdrawn from operations. It is worth noting that the standard Lancaster was valued so highly by command for its ability to carry a massive bomb load that it was never assigned in any numbers to units whose sole task was suppressing enemy radar. Alongside the modifications made for carrying super heavy bombs, the designers also kept improving the bomber's defensive armament during production. For example, the Fraser-Nash 64 ventral turret was often removed from Lancaster Mark I aircraft and was almost never fitted to Lancaster Mark III aircraft. By the end of 1944, most operational squadrons were flying without them at all. The only exceptions were aircraft modified to carry bombs approaching 8,000 pounds, where those lower positions were retained. In any case, the lower turret had to be removed if the aircraft was fitted with the H-2S radar system. And since by the end of the war those radar sets were installed on nearly all Lancasters, the need for ventral gunners disappeared on its own. Starting in 1943, the engineers also experimented with armament fits. Aircraft began receiving different Fraser-Nash dorsal and tail turret arrangements, including the Fraser-Nash 79 and Fraser-Nash 150. One especially interesting example was the Fraser-Nash 82 tail turret. Its main distinction was that instead of 4 standard .303 caliber machine guns, it carried 2 powerful .50 caliber Browning machine guns. The same hard-hitting combination of twin Brownings was used in the special Rolls-Royce tail turret, seen on some bombers in the fall of 1944. And in the final stretch of the war, a few Lancasters received something genuinely futuristic for the time: the fully automatic AGLT tail turret, known by the code name Village Inn. It had an integrated radar sight that could automatically aim the tail guns at an enemy fighter and open fire in the night sky without direct human control. In the spring of 1945, the latest American-built Martin electrically powered turrets began arriving in Great Britain. They were armed with 2 .50 caliber Browning machine guns. Command decided to install these modern defensive systems in 180 Lancaster heavy bombers ordered from Austin Motors. In March of that year, one Lancaster Mark III received such a turret. Later, however, that specific aircraft was used as a flying testbed for other defensive systems as well, including a B-17 upper turret with twin guns described in the original source as .79 caliber, and a B-32 ventral turret with twin .50 caliber Brownings. The upper installation was placed much farther forward than the usual Fraser-Nash 50 turret. That same month, Austin began delivering production bombers of the Lancaster Mark VII model. These aircraft did not arrive in time to see action in the Second World War, but they later served successfully in several squadrons in the Far East. Interestingly, between February and April 1945, 50 non-standard Lancaster Mark I aircraft also came off the line. They had originally been intended as the 7th model, but because of an acute shortage of Martin turrets, they were fitted instead with older Fraser-Nash 50 turrets in a new forward position. Although no Lancaster squadron actually flew combat operations in the Middle East or Far East before the war ended, plans to send them there had been under development since 1943. To understand how the aircraft needed to be modified for tropical service, 2 Lancaster Mark I aircraft were sent to India. There, at the base at WWII, they spent a full year beginning in October 1943 undergoing intensive trials with 1577 Special Duties flight. During that same period, the heavy bombers also took part in interesting experiments as tow aircraft for the giant HOR Sioux and Hamilcar transport gliders. That was an integral part of the effort to develop new glider tactics for the Indo-Burma theater. Toward the end of 1944, the scheme for tropical adaptation was finally settled. Aircraft specially built or modified for hot climates were meant to operate alongside the new Lincoln bombers in Tiger Force, the long-range strike formation intended for major attacks against Japan. In August 1945, Command seriously planned to send a large force into the Pacific. It was to include 83, 97, 106, and 207 squadrons, along with 467 Squadron of the Royal Australian Air Force and 75 Squadron of the Royal New Zealand Air Force, all fully equipped with tropicalized Lancasters. To give the aircraft the tremendous range needed for Pacific operations, Avro developed a unique solution. The engineers created a massive auxiliary fuel tank holding more than 1,440 gallons. It was mounted along the upper fuselage from the pilot's cockpit to the position of the dorsal turret, which had to be removed to make room. These saddle-backed Lancasters could cover remarkable distances, but the war ended before they could be used in large-scale operations against Japan. At the same time, the Lancaster was also adapted for transport work. One notable post-war conversion was the Lancastrian, a more civilian version built from the bomber. On top of that, the engineers created another interesting passenger and cargo aircraft, the York. It had an entirely new fuselage but retained the proven wings and power plant arrangement of its famous predecessor. In the post-war years, these aircraft were often used as flying laboratories. Different engines were tested on them, early in-flight refueling systems were tried out, and new equipment was evaluated. But the Lancaster's main legacy remained the enduring fame of the heavy bomber itself. Today, the memory of this remarkable aircraft lives on in the single example that can still take to the air. It is proudly maintained in perfect condition by the Royal Air Force Battle of Britain Memorial Flight. Meanwhile, during the Second World War, Soviet aviation suffered from a serious shortage of heavy bombers. The aircraft factories of the Soviet Union were critically overloaded with production of small tactical aircraft and simply did not have the resources to equip the military with a substantial fleet of large multi-engine bombers. The only Soviet heavy bomber built during that period was the PE-8, and only 79 of them were produced. Through official Allied aid channels, the Soviet Union received very few aircraft of that type, only a single American B-24D Liberator and a few British Sterlings. Even so, by the end of the war and in the first post-war years, Soviet aviation still acquired a certain number of Western-built heavy bombers, mostly aircraft that had made forced landings on Soviet territory and were never returned to the Allies. Among them were a few Avro Lancasters. In September 1944, Soviet and British command joined forces for a combined operation known as Paravane. Their main target was the German battleship Tirpitz, which at that point was sheltering in Norway's Aalta Fjord. Although the huge ship had already been damaged several times, it remained a very serious threat to the northern convoys sailing from Great Britain to the Soviet Union. To finish the enemy warship once and for all, an entire air group was sent to the Yagodnik airfield in the Arkhangelsk region. It consisted of 38 Lancaster heavy bombers, 2 Liberator transport aircraft, and 1 Fast Mosquito reconnaissance aircraft. The formation was made up of aircraft from 6 17 Squadron and 9 Squadron of the Royal Air Force. The Lancasters were fitted with Rolls-Royce Merlin 24 engines and were intended to carry 12,000-pound heavy bombs. Visually, these aircraft differed from standard bombers. They had deep, almost pot-bellied bomb bays and lacked the dorsal turret, which had been removed to lighten the structure. Beginning at 6 o'clock in the morning on September 12th, British aircraft started arriving at the airfields of the Arkhangelsk area. But the ferry flight turned out to be difficult. For various technical and weather-related reasons, 10 bombers made forced landings at Oneka, Bielomorsk, Kagostrov, Severodvinsk, and even out in the wild tundra. One of the aircraft landed in such a remote and awkward location that rescuers had to parachute in a guide. He led the crew out on foot to the nearest river, where a Soviet MBR-2 flying boat was waiting for them. In all, 7 aircraft were damaged during the transit, and one of them was completely repaired through the joint efforts of Soviet and British mechanics. The decisive strike came on September 15th. That day, 27 Lancasters, including the repaired bomber, dropped their deadly load on Tirpitz. Soviet navigators guided the British crews to the target. Soviet aircraft had also carried out preliminary reconnaissance of the area and later photographed the results of the raid. The British dropped 21 powerful Tallboy bombs, while 6 other aircraft carried standard armor-piercing bombs weighing 494 pounds each. One of the giant bombs struck the battleship directly, and several of the smaller weapons also hit. Despite the terrible damage, Tirpitz somehow remained afloat. The British suffered no losses in this attack. Between September 16 and September 28, all surviving and airworthy Lancasters successfully returned to their home bases in Great Britain. Interestingly, the British did eventually manage to finish off Tirpitz when the Germans tried to move the damaged ship to a new location closer to the island of Hakoya.